Okay, let's do 15.1, and it's going to be an introduction to radicals. So you've all seen radical. It's just a name for a symbol that looks like this. And you probably know that is the square root symbol. So we're going to really just restrict ourselves to square roots. When you get to intermediate algebra, you'll be introduced to something else. So let's talk about the square root. So this this symbol indicates a special type of a square root. So let's define square root. So the square root of a number b is another number s such that s squared is equal to b. So for example, if b is our number, 25, then a square root of 25 is another number s such that s squared is equal to 25. So let's let s equal 5. Then 5 squared is 25. Hence, s equal 5 is a square root of 25. Let's do one more thing here before we look at some examples. I want to show you that every positive number has two square roots. Let s equal minus 5. Then minus 5, that's our base, squared, is also equal to 25. Hence, minus 5 is a square root of 25. So this tells us this following principle. Every positive number, and of course we're talking about real numbers, has two square roots. So this is something that you need to know. And here is the thing. This symbol right here, well, okay, that's a lot of choices. This symbol right here didn't draw it very good. That b greater than 0, then, so this is just a symbol, denotes, here we go, the positive square root of b. So let's look and use that symbology on my last two examples. So we just call that, this symbol, I like to call it the positive square root. So the positive square root of 25 is equal to 5. Why? Because 5 is a positive number. When I multiply it by itself, I get that. So with that in mind, what would be the negative square root? Well, if this symbol right here denotes the positive square root, then the negative square root of 25 would be minus the positive square root of 25 which just gives me minus 5. So keep those things in mind, and let's just look at some examples. Really, the only thing we're going to do right now is find square roots. And what we're going to do is use the fact that this symbol right here that you're seeing always denotes the positive square root, and we're going to use the definition. We're not going to use a calculator, we're going to use the definition. So for 1a, we want to find the positive square root of 49. So we're looking for a number b where b squared is equal to 49. And of course, the number b we're going to be looking for is going to be greater than 0 because we're looking for the positive square root. So if I let b be equal to 7, then b is greater than 0, and b squared is 7 squared, and that's equal to 49. So the square root of 49 is 7. (1b). We want to find the positive square root of 1 over 36. So again, we're looking for a b, a real number b, that is greater than 0, where b squared is equal to 1 over 36. So the trick here is to note that whatever b is going to be, it's going to be 1 over some number k, and 1 over some number k squared is equal to 1 over 1 squared over k squared, which is equal to 1 over k squared. So really this problem reduces down to finding out some number k greater than 0, where k squared is equal to 36. And clearly, if I let k be equal to 6, then k squared is equal to 36, and the answer then is 1 over 6. So to make that a little bit clearer, when you have a fraction, what you do is you I'm going to give you a rule, although it's not been introduced yet. What you do is you look at the numerator and you find the positive square root of the numerator, and the square root of positive square root of 1 is always 1. And then you just look at the denominator and you find its square root, and the positive square root of 36 is 6. So it turns out the square root of 1 divided by 36 is exactly the same as the square root of the numerator divided by the square root of the denominator. And as a matter of fact, the equivalence of these two symbols will be given to you later on. But for right now, we're just kind of getting used to using positive and negative. Just actually getting used to using the definition. So for C, we want to find the negative square root of 9. So again, that's the same as minus the positive square root of 9. So all I really have to do is find some number b greater than 0 such that b squared is equal to 9. 3 fits the bill nicely. So the square root of 9 is, the positive square root of 9 is 3, so the negative square root of 9 is minus 3. Now D is kind of a trick question, but it's put there so we will actually learn something really important about square roots. And that's the whole point about using the definition in this example. So we want to find the positive square root of minus 100. So again, back to the definition. I want to find some b greater than 0 where b squared is equal to minus 100. Well, any number greater than 0 squared is positive. So I cannot find some number b greater than 0 where that number times itself is equal to a negative. So the answer is no such. Here I'm going to put this in just to kind of foreshadow real number exists. And for you guys, we're only talking about real numbers, but when you get to intermediate algebra, we'll actually find that this does have a square root, but it's not a real number. So you don't have to worry about this real number part right here, but we have to be accurate. And when you see that the square root of minus 100 in intermediate algebra is going to be called 10 times I, where I is called the imaginary unit. So it's it's a complex number with a non-zero imaginary part. But you don't have to worry about that. It's coming up. You'll get there sooner or later if you have to go that far. I don't know what your programs are, but many of you will have to deal with that. So you saw it first here. So now let's find the square root of 25 over 121. So we can break this down into two parts. I want to find some number a greater than 0 where a squared is equal to 25. And then I want to find some number b greater than 0 where b squared is equal to 121. Well, for the first, a is equal to 5 works because 5 times 5 is 25. And for b, if I let b be equal to 11, then 11 squared is 121. So the square root of 25 over 121 is equal to a over b, which is 5 over 11. And notice 5 over 11 is also greater than 0. So we can check it again. So 5 elevenths is certainly greater than 0. And 5 elevenths squared is equal to 5 times 5, which is 25, and 11 times 11, which is 121. And that's exactly what we were looking for. Now, here is a next one that's, you don't like them, but let's just go back and review our decimal multiplication. We want to find the square root of 0.64. So that's going to be some number b greater than 0, where b squared is equal to 0.64. Well, you probably know that this is going to be related to a question, a similar question, some number c greater than 0, where c squared is equal to 64. Well, let's answer this one. Well, some number c greater than 0, such that c squared is equal to 64. Well, if c is equal to 8, then 8 squared is equal to 64. Well, what do I do here? Notice that the decimal point from 64 to 0.64 is moved over 2 places. So if I multiply 0.8 times 0.8, that's going to be like multiplying 8 times 8. And what did I do? I moved it over 2 and moved over 2. So I have to move it over 4 places, and that's not what we want. So we go back and say, okay, it wasn't 0.8 times 0.8. What about 0.8 times 0.8? Well, remember, how do we figure that out? This is multiplication here. I figure out the corresponding problem. by multiplying, moving the decimal over one place, and then computing 8 times 8, which is 64, totaling up the total number of places I moved, and then moving it back there, and that's what I want. So the whole point is that the answer is, with a leading 0, 0.8. Why did I go through that? Because the most common wrong answer given is 0.08. And I just showed you how to calculate that. So be careful. So let's recap. You just kind of find the square root of 24, and you take the number of places it's been moved, and that's 2, and you divide that by 2, and that gives you 1. So you move 8 times 8 is equal to 64. So you move the decimal place over 1 to get 0.8 times 0.8, and that gives you what you're looking for. So now let's do variable expressions. So here they're making a really important point, and I'm glad they are. They're wanting you to recall, or to assume rather, that all of our variables represent positive numbers. Now when you get to intermediate algebra, you won't have that assumption, and you'll have to do a special little operation at the end. So let's think about this. Square root of x squared. And I already know that x is greater than 0. So I want to find some other number. X times x is x squared. That's it, right? That's literally the square root of x squared if x is greater than 0 is equal to x. So let me show you what we're doing here. I'm going to kind of give you an indication. So we're not talking about it here, but this radical, so this symbol right here that I've drawn, the symbol itself is called a radical. In particular, we don't really call it the radical too much. We call it the square root symbol because it's so common. But there's going to be other types of radicals you deal, and each radical has a number called an index. For the square root symbol, that index is understood to be 2. That's because it's squaring. But we don't write it when it's the square root. So what we do is when we have a number squared, and we're assuming that the number is positive, and we know the index is 2, the answer is what's under the radical divided by the index. And for this, the index for you guys is always going to be equal to 2 and will be unwritten. So I just gave you a little bit of information that you'll deal with later on. So that was a little bit easy. All of this is easy. The next one we want to do is a to the 4th. So we're going to use that rule. We want to find the square root of a to the 4th. Well, that's going to be equal to a to the 4 divided by 2, which is equal to a squared. So to recap, the square root of a to the 4th is equal to a squared. The next one we're going to do is m to the 8th. So these are pretty easy. the square root of m to the 8th is equal to m to the 8 divided by 2, which is m to the 4th. Then we're going to do the square root of 81x to the 4th. So 5d. The square root of 81x to the 4th. Well, I'm going to go ahead and give you a little rule here. That's equal to the square root of 81 times the square root of x to the 4th. This is known as the product rule, and I don't see any reason to require you to figure this out any other way. And you're going to be introduced to the product rule. This is the product rule for radicals, in particular square roots. So we know that the positive square root of 81 is 9, and that the square root of 84 is x to the 4th power divided by 2. So it's 9x squared. Notice what we're doing. The end result, the radical signs have been removed. Failure to remove these radical signs for your end result, when you can indeed remove them, or they should be removed, is a common error in this section. So let's do 10e. I didn't print this out, and I can't scroll up on the page because this is literally the last of our exercises. These are all going to be really short videos. I'm going to try to get them all done today. So let's do 5D, or whatever it is, 5, A, B, C, D, E, F, G maybe. The square root of x to the 10th, y to the 8th, z squared. Well, by that rule I just cited, it's called the product property of radicals. That's the same as the square root of x to the 10th times the square root of y to the 8th times the square root of z squared. Isn't it nice that all of these numbers are even? Well, that's going to be equal to x to the 10 divided by 2 times y to the 8 divided by 2 times z to the 2 divided by 2. So this property of dividing by 2 only works when the power is even. So the answer written in standard form is x to the 5th, y to the 4th, z. So let me recap the summary here, because I don't know that I can't remember back far enough to make sure if I stated that clearly. Rule: let, and this is important, n be an even natural number. For example, numbers in the set of 2, 4, 6, 8, 10, etc. And let x be greater than 0. Or in general, any variable be positive. Because sometimes they don't use the variable x. And then here is the conclusion. Then the square root of x to the n is equal to x to the n divided by 2. Final note, we will have A modified rule when n, the exponent, is odd. Okay, that's it for this lecture.